right, so I told you to go through and just find f of x. That's all I wanted you to do. So we have these limit statements. So we can have the limit as x approaches a number or the limit as h approaches 0. So remember, if it is the limit as x approaches a number and you can tell that it's the definition of a derivative, then you're just getting your function from right here. 2x squared minus 2x to the 4th. Okay, easy enough? We agree with that? All right, so if you have an, as h approaches 0, you're going to have an h in there. But remember what you're doing is, it is f of x plus h minus f of x all over h. So your f of x here, remember f of x plus h, so that makes this my x. This would be x plus h, but x plus h replaces x, so this is just an x cubed minus, and then this would be x plus h, which would just be x squared. See how to get that from there? Any questions on those? All right, I have another h approaches 0, but instead of having a number like -4, this is just x plus h. So remember, x plus h replaces x, so that means my f of x here is, and if I don't have a number that's, I can just get it from right there, or look at how you get it from here. This becomes x, so 5x squared plus x to the 4th, and that's what I have right there, 5x squared plus x to the 4th. Okay, we all good? All right, so then I have the limit as x approaches 1. So where do I get my function from? The first thing right here is just 5 over 3x. You're going to make your life a lot harder if you write things like that. All right, so I have as h approaches 0, so I can clearly not just grab either one of these, right? I have to think about the fact that what we replace x with is x plus h, right? And when you have two numbers in here, you got to, which one of them is x. This is your x plus h, so this would be x minus 1, so it's the square root of x minus 1. You see how that works? No? That's fine. X minus 1, because we're going to have to change that to that in just a second anyway. All right, any questions on the front? Because your first thing here is we got to get f of x out of here. All right, so f of x. So since it's, as x approaches a number, and I can tell it's the definition of the limit, it's just right there, square root of x plus 1. All right, number 7. F of x would equal, what is it going to equal? 2 over x plus 3. Good. Because I can get a function from right there, or I can see that this would be my x. Okay. Any questions about why these are what they are? Because if you're not sure how to pull them out of there, that's the problem. All right, f of x equals, on number 8, this is as x approaches a value, so that one's pretty easy, right? 3 times the secant of x. And remember, it's the secant of x. I cannot multiply the 3 and the x. It doesn't work that way. Everybody good with that one? All right, so 9 f of x equals, so it's the limit with h. So I got to think about my x plus h here. So if this would be x plus h, then that means I just have 2 times the tangent of what? X. Okay. And my last one, f of x equals 2 secant x. What questions you got? You got all those okay? All right, so now I want you to go back to the front. And now I want you to go through, and just the 5 on the front, I want you to find the derivative. Okay, find the derivative. I'll give you a few minutes to do that. Of each one of them, just 1 through 5. Just the front. and talk to each other. When you're done, I do want you to compare to each other. What are y'all thinking? Okay, quotient rule would work. If you don't know what else to do, you can do quotient rule. Are there other options? Yes. If you don't know what they are. -3? There would be no -3. The power would be negative, but the 3 would not be negative. And then you can use chain rule. Yeah. That works. Then, so that's a safe stop. But if you had to match it to something where so a safe stop that's fine. If you're going to actually use it or maybe have to match it with something, then you wouldn't want negative exponents. So what else would that look like? Could you go one more step? I'm not saying you're wrong. I'm just saying see if you can take it one more step. Maybe even 2 more steps. Just try it. You're fine there. That would be a safe stop. But remember, sometimes you have to match it to things. I'm going to walk you through it in a minute too. So. You can do quotient rule. And honestly, it may be that negative exponents mess you up and you make mistakes on them. And so maybe quotient rule is safer because it will be simple since the numbers are simple. And you can just knock it out and go through the pattern. You're good. You're not wrong. You can take it a little farther. Good. Could you take it even farther than that without making up math? Again, not saying you'd always have to, but if this was multiple choice, it may not match that. Yeah, so you can square this and then you'll be able to reduce it. Yeah. Good. Good. All right, so let's go through these. I think we all took a little bit longer on number 4 than the rest, right? So hopefully this one was pretty simple. We get 4x minus 8x cubed. Yes? Okay. For this one, we don't have to do anything fancy here either. This will just be 3x squared minus 2x. We all agree with that one? Okay. So then, number 3, f prime of x would equal 10x plus 4x cubed. We all agree with that? Okay. So this one, we could work one of 2 ways, and I think maybe I'll work it both ways so that we can just look at the differences here and where our safe stops are. So how many of you use the quotient rule? Okay, so I think more people use the quotient rule than not. So I'm going to do it with the quotient rule first, and then I'm going to do it the way Marco did it and the way I did it. But again, one's not better than the other. It's whatever makes the most sense to you. And I have a feeling if you didn't do the quotient rule, some of you might make some mistakes at some point. So, and we don't want that to happen. I'm going to start with the quotient rule. So I have f prime of x equals, so I take the derivative of the top, of the first, which is 0, times the bottom, minus the top times the derivative of the bottom, all over the bottom squared. Right? We agree with that? Is that a safe stop? Yeah, it's a safe stop. We've put it all in there. It's a safe stop. But again, if we needed to take this farther, this would give us negative 15 over, oops, we could leave it as 3x squared. Like maybe that would match something, right? Maybe that would be it. Or, oh, I did that wrong. Right there. And then this could become negative 15 over 9x squared, which would reduce to negative 5 over 3x squared. In parentheses matter here. Okay? So the other way to look at this, if you didn't want to do quotient rule, is I can make this into 5 times 3x to the negative 1 power. Then I can use the chain rule. Right? And I can say that f prime of x equals, so I take care of the outside, negative 1 times 5 is a negative 5 times 3x, and then I subtract 1 to the negative 2 power. Then I have to take the derivative of the inside, which is 3, which does give me that is negative 15 times 3x to the negative 2 power, right? Which again is a safe stop. Even this is a safe stop, as long as you have all your parentheses and stuff in the right place. But then I could make this into f prime of x equals negative 15 over 3x quantity squared. And then I'm right here at this spot, and then I could reduce it if I needed to. Okay? So again, whichever one makes the most sense to you, it's fine. One really isn't more steps than the other. And if you know you could do it with negative exponents, but you're like, you know what? I'm afraid I might not subtract the 1, or I might do something weird, or put the negative on the 3 or something like that, then do it this way. You kind of just have to decide whatever you would rather do. Okay, we good? Questions? Okay, good job. All right, so then this one, should we rewrite number 5 somehow before we take the derivative? Yes, we should say that this is x minus 1 to the 1/2 power. Okay, which is maybe what you put first. So f prime of x, that's going to give me 1/2 times x minus 1 to the negative 1/2 power. Technically, this is chain rule. So when I do all that, then I have to take the derivative of the inside. What's the derivative of this? 1. Okay, so that's why sometimes you might feel like you're just not doing it or you're leaving it off. It's 1, so we don't necessarily have to write it. And then I would write this as, because in the end, you really don't want to leave negative exponents if you're going to have to do something with it. So 1 over, so that 2 goes down there, and then this is the square root of x minus 1. Okay? We good? What questions you got? All right, flip it over and do the derivatives on those. And remember, psst, when you need to. This one. Nothing math, Jill, sweetheart. We don't want that. Mm-hmm. It's so dramatic when you finish. Is it really that easy? Because are you sure this is right? Are you sure that's right? Psst. No, that's not what you put. That's why PSST, tangent is secant times secant, secant is secant tangent. There's no square. That's right. You better not. I will haunt you. What happened to the 3? It doesn't disappear because, like, if you were just taking the derivative of 3, it becomes 0. But there, it just kind of stays in front of it. Kind of like if I had 2x cubed, that 2 stays there, and that becomes 6x squared, right? Okay, same concept there. Why is this 2 and 2? 3 and 3. You're making stuff up, man. Yeah, you keep the 3, and this changes to secant tangent. Yeah, you put another 3. It's 3 times secant tangent. No. There's no distribution, there's no addition sign there. Well, I'm sorry if you think it's dumb, but it is what it is. Yes, you leave that there. Because it's like, so like if I had 2x cubed, that 2 doesn't disappear, it stays there, and that becomes 6x squared, right? So same kind of thing, the 2 stays there, and you just do the rest. When you think it disappears, that's when it like stands alone. If it was like plus 3, then the derivative of 3 is 0. Okay, let's see what happens here. Are we all done? Almost done. Sorry, you're still right. Almost. Okay. Why are you doing all this? You can do chain rule there, but you don't need to. I'm sorry, product rule. You can do product rule, but you don't need to because this doesn't have a variable on it. Does that make sense? So you end up with the same answer, and it's not wrong. You just don't need to do it, so you want to make sure you're not trying to make things more difficult. Right, so think about it the same type of thing like what I just showed her. If I have 2x cubed, I could do product rule, right? But I don't need to because I know that this becomes 6x squared, right? Same type of thing. Yes, this is a product, and you're right, but it's not a product of 2 functions. Does that make sense? Okay. So just make it a little bit easier on you to. Yeah. So like if I had 3x squared times secant squared, something like that, then that is a product of 2 functions there. Okay. All right, so let's look back up at number 6 here. So I went ahead and rewrote it because we got to rewrite it, right? So we should have f prime of x equals, so we'll have that 1/2 times x plus 1 to the negative 1/2 power. This is chain rule, so the derivative of x plus 1 is just 1, so I'm not going to bother putting it. And then I'm going to rewrite it without my negative exponent. This is 1/2, so 1 up here, 2 down here, square root of x plus 1. Okay, we're all okay on that one? We're on that one. Okay, so on this one, once again, you could do it one of two ways. You could do quotient rule, you could change and use a negative exponent. Doesn't matter either way. I'll work it both ways again, just so that we kind of get the idea here. F prime of x, so if I was going to do quotient rule, I take the derivative of the first, so that's 0, times the second, which is x plus 3, minus the first, which is 2, times the derivative of the second, which is 1, all over x plus 3 squared. So that means this whole thing right here zeroes out, so I get negative 2 over x plus 3 squared. If you would prefer not to do quotient rule, you can make this into 2 times x plus 3 to the negative 1. Leave a lot of room there. So that we would have f prime of x is equal to, so negative 1 times 2 is a negative 2 times x plus 3 to the negative 2 power. Chain rule, so I take the derivative of the inside, which is just 1, so I don't need to put it there. So f prime of x is equal to, so this is not a 1/2 like it was there. That negative 2 stays in the numerator. Denominator, x plus 3 squared. I do think that if you make the kind of mistakes where you're not sure what goes in the numerator and denominator in these cases, that you might be better off doing product rule because it puts everything in the right spot. And that way you don't get your negative exponents mixed up and those sorts of things. But again, it's personal preference. As long as you can do it and it makes sense to you, doesn't matter either way. We good? Yes, sir. Oh, my goodness. You can't wait till we're done. But I'm pretty sure I spelled your last name wrong. I'm sorry. All right. So then here, so there was some question or some confusion about what happens with this 3. Okay? So this 3 is just like if it was a 3x, like, because remember that your rules for derivatives, it's just 3 times whatever this derivative is. So I can just take the derivative of this, I leave the 3 on there. So the derivative of secant is what? Secant tangent, because remember the P-S-S-T, you ignore the P. Derivative of tangent is secant times secant, which is secant squared. Derivative of secant is secant tangent. So this is just 3 secant x times the tangent of x. Okay? No squareds on there. Then here for f prime of x, that 2 just hangs out there. What's the derivative of tangent? Secant squared x. And then here, f prime of x is 2 times what? Secant x, tangent x. Okay. Everybody good with all that? No. Flip it back over to the front. Now we have to decide, so each one of these, no matter what, we had to find f of x, and then we found the derivative, right? Because the limit is the derivative. And so really the pink part is the derivative itself. Then you have to decide whether or not you're evaluating this at some number. Well, this one's real clear, right? It's at negative 2. So that means we take, and we want to do f prime. So f prime of negative 2 is going to be 4 times negative 2 minus 8 times negative 2 cubed. So this is going to give me negative 8. What's negative 2 cubed? Negative 8 times negative 8 is positive 64. So f prime of negative 2 equals 56. Okay, so that's what it equals. What this represents, what this means, like if you maybe it wasn't asking you to do all this. This represents the derivative of this function evaluated at negative 2. right? Does that make sense? So that's how one of those questions was asked on there. Okay, so on number 2, am I actually going to evaluate this at some number? Yes. And what's that number? -4, because this is your x plus h, so that's it right there. So we're going to do f prime of -4. That's equal to 3 times -4 squared minus 2 times -4. It'll be 3 times 16 plus 8. 3 times 16 is 48 plus 8. And f prime of -4 is 56. What if all the answers are 56? Okay. So that's our final answer. Now, on number 3, are we evaluating this at some value? No, because it doesn't say it right here, and this actually has an x in it. So your final answer to this one is that f prime of x equals 10x plus 4x cubed. Okay, I'm just rewriting it so you understand that it's not that we didn't do anything there. That's all we can do on that one. That's what they're asking. All right, on number 4, are we evaluating it at some number? Yes, at 1. So f prime of 1 is going to equal -5 over 3 times 1 squared. So f prime of 1 is just -5/3. On number 5, are we evaluating the derivative at some value? 2, because this is my x plus h right here, right? So I'm evaluating it at 2. So f prime of 2 equals 1 over 2 times the square root of 2 minus 1. Get used to plugging stuff in like that, because that's a safe stop, especially if things got crazy, you know? So that just means that f prime of 2 is equal to what? 1/2. Okay. What questions you got? All right. Are we evaluating number 6 at some value? Yes, at 3, right? So f prime of 3 equals 1 over 2 times the square root of 3 plus 1. So 3 plus 1 is 4, square root's 2, so it's just 1/4. Are we evaluating number 7 at some value? No. So my answer is f prime of x equals -2 over x plus 3 squared. And just FYI, this is the same as -2 over x plus 3 squared. My suggestion to you, though, because I feel like sometimes I'll do weird things with the signs and fractions, if when you're doing this, if that -2 was in the numerator, leave that guy in the numerator. Like, don't move it around unless you're reducing things so that you don't accidentally say something you didn't mean to say. Right? So this is okay, but just, again, you don't want to get something wrong because you just put a stupid sign in the wrong place. All right, am I evaluating this at some value? Yes, 5π4. So f prime of 5π4 equals 3 times the secant of 5π4 times the tangent of 5π4. All right, so can I multiply the 3 times the 5π4? No way. All right, so secant is the reciprocal of what? Cosine. So what quadrant is 5π4 in? The third. In the third quadrant, is cosine positive or negative? Negative. And cosine would be a negative what? Square root of 2 over 2, which means the secant is just negative square root of 2. Tangent in the third quadrant, positive or negative? Positive. What's the tangent of a π4 angle? 1. So f prime of 5π4 is -3 square roots of 2. Get y'all knowing your unit circle makes me so proud. All right. Yeah. That's right. That's what I was trying to do, is just torture you until it's like you're traumatized and you know it. Okay, am I evaluating number 9 at some number? Yes. What is that number? 5/3. Remember, pi thirds, I'm sorry. That is your x plus h there. So f prime of pi thirds, that is equal to 2 times secant squared of pi thirds. All right, so we already decided that secant is the reciprocal of cosine. What's the cosine of pi thirds? 1/2. The reciprocal of that is 2. I square it and I get what? Yes. Yeah, I know what you mean. I square it and I get 4, then I multiply by 2. Yeah, I get 8 in the end. If you need to write intermediate steps down, please do so that you don't do weird stuff. Okay. Am I evaluating number 10 at some number? No. If you literally see the x plus h in there, see, this represents x plus h. That's how I knew there was something there when it's an h. So then that means here that my final answer then is just f prime of x equals 2 secant x tangent x. Okay. What questions you got? All right. Your test is Friday.